let's do a calculation where we look at formal charges to determine the best Lewis electron dot structures. We're going to say, what is the SO bond order in the sulfate ion? SO4 minus 2. Now, in order to do that, we need Lewis electron dot structures. And to do that, we need to draw them all the various resonance structures, and determine the best ones based on formal charges. So let's look at a few. Here's Lewis electron dot structure number 1 for sulfate ion. You can see I've distributed the electrons around the atoms and bonded this all together. All the rules for Lewis electron dot structures are followed for this molecule. Now, let me assign formal charges. To assign formal charges, I count the electrons around the oxygen here and compare it to the atomic oxygen. Here, I have 1, 2, 3, 4, 5, 6, 7. Remember, when I'm doing formal charges, I share the electrons. So 1, 2, 3, 4, 5, 6, 7 electrons around the oxygen. Oxygen normally has 6 as an atom, has 1 extra. That's a -1 formal charge. All those oxygens are the same. So they all have -1 formal charge. The sulfur, I'll share electrons in this bond. So I'll get 1 from that bond, 1 from that bond, 1 from that bond, and 1 from that bond, a total of 4. Sulfur normally has 6, so it has 2 fewer. It'll have a +2 formal charge. So there we've determined the formal charges for that Lewis electron dot structure. Not the only Lewis electron dot structure we can draw for this. Here's another one where I've expanded the octet for sulfur. And we can expand the octet for sulfur because sulfur is below row 2 on the periodic table. It's a larger atom, more orbitals, and can expand its octet. Is this one better than this one, is our question. Well, let's again calculate formal charges. Here, oxygen, 1, 2, 3, 4, 5, 6. Again, these 2 lone pairs are assigned to that oxygen. And this double bond has 4 electrons, and I'm going to share them. So 2 electrons are assigned to the oxygen, plus these 2, 6 electrons are assigned to oxygen. It normally has 6 as an atom, so formal charge of 0 there. This oxygen is identical, so it'll have a 0. And these oxygens look just like these oxygens. They have formal charge -1 again. The sulfur, let's calculate its formal charge. 1, 2, 3, 4, 5, 6 electrons shared in the bonds around sulfur. 6 electrons, as an atom it has 6. So it has a formal charge of 0. So notice here we have now fewer formal charges, and our negative formal charges are on the more electronegative elements. That's kind of attractive. So here we have a lot of formal charges, and they're distributed around the whole molecule. Here fewer, got a lot of zeros here, and the electronegative elements have the negative formal charges. I could continue sharing electrons, another resonance structure, where now I have expanded the octet of sulfate again, sulfur having 1, 2, 3, 4, 5, 6, 7, 8 bonds around it. We know these oxygens are similar to these oxygens, so they'll have formal charge 0 again. The sulfur shares 1 electron from each of these 8 bonds. That gives it 8 electrons around it. 8 electrons around it in this molecule compared to the 6 it normally has as an atom means it has a -2 formal charge. Now here I have a lot of 0 formal charges. That's nice, but I have a -2 on a lesser electronegative element. When I compare sulfur and oxygen, oxygen is the more electronegative. And I'd rather have the formal charges negative on the more electronegative elements. So this Lewis dot structure I don't like a lot because of the numbers and distribution of formal charges. This Lewis dot structure, I've got a negative charge on the less electronegative element. So those two I don't like as much as I like this one, which has low formal charges, and the negative formal charges are on the more electronegative element. So if I calculate the bond order here, I think it's pretty obvious. The bond order is 1 in an SO bond here. An SO bond here, I can see 2 single bonds, 2 double bonds. I'll get a bond order of 1.5. Here, it's obvious that the bond order is going to be 2. All of them are identical and double bonds. So I'll have a bond order of 2 here. But I'm going to reject these 2 Lewis electron dot structures based on their formal charges. And I'm going to call this, with the low formal charges and more electronegative elements with the negative formal charges, the best Lewis electron dot structure. So I'm going to call the bond order here in sulfate 1.5.